Okay, now let's continue with problem 2. So here you'll be using Hessel cycle or Hessel triangle to solve delta H of a reaction by using extra information here, additional information here. So you're given the enthalpies of formation of phosphorus oxide, water, and phosphoric acid with these values. Using this data, construct a Hess-law triangle and calculate the enthalpy change for the following reaction. So your main is to calculate delta H for this reaction. Okay, and you are given enthalpies of formation. Okay, so delta H of formation of phosphoric acid, okay, is minus 2,984 kilojoules per mole. Okay, and delta H of formation of water is minus 286 kilojoules per mole, and enthalpy of formation of phosphoric acid minus 1,279 kilojoules per mole. Okay, this is additional information. Yeah, and remember, just try to understand what these values mean. So delta H of formation, it means it's a heat change when you form this substance, phosphorus oxide, from its elements. Yeah, so you're forming this substance, water, phosphoric acid, from its elements. So the upper part of the triangle is already given. So using this additional data, you should write the bottom of the triangle. Okay, so if you're forming, that means you are forming the substance from the elements, yeah, from its elements. So what kind of elements do we have in phosphorus oxide? Yeah, so you are forming phosphorus oxide, delta H of formation, from its elements. We have phosphor and oxygen. Okay, and so this is all given, delta H of formation of phosphorus oxide, and you're given delta H of formation of water. So again, you are forming water, 1 mole of water, from its elements. So what elements we have? So we have hydrogen and oxygen. Yeah, oxygen is already written here, and you just add hydrogen. Okay, so given. And the next, we are given delta H of formation of phosphoric acid, again from its elements according to definition. So I'm referring to definition here. So what type of elements do I have here in my phosphoric acid? I have hydrogen, which is already written, phosphor written, and oxygen written. Okay, so I'm just forming it. So I'm going from its elements to form that substance. Okay, so it's also given delta H of formation of phosphoric acid. Okay, and delta H of formation of water. And here you just need to balance. So this equation is already balanced. So I have no, it's not already balanced. Yeah, it's already balanced. Sorry. So I have 4 phosphorus and how many oxygens? 16. Yes, 8 oxygen here and 12 hydrogen. So 6 hydrogen here. Okay. Okay. Now, so I put my arrows here. So because I'm forming substance, I'm going from elements to the substance, yeah? And my main arrow will always go from the reactant side to the product side. Okay, this is my main arrow here. Okay, so to find delta HR, I just follow the arrows, the direction of the arrow. Delta HR equals to the sum of all delta H of reactants, and but here, so in delta H of reactants, yeah. So look for the arrows of your reactants. Okay, delta H of arrows. So these arrows, yeah, this one, reactants ones, they lie in the opposite direction with the main dashed line here. These arrows are going from bottom to right, up. This one is going the other way around, from top to bottom. Yeah. So therefore, I have to put minus in front of delta H of reactants. Okay. But my product side, this arrow, is going in the same direction as my dashed line here. Therefore, I put positive sign in front of my product's delta H. Okay. Okay. Now we agreed on the signs. Yeah. Now let's put the numbers. So delta H of reactant. So it's a phosphorus oxide formation. Okay. It's minus 2,984 kilojoules per mole. Okay, so I have I don't multiply by any number because I have 1 mole of phosphorus oxide, and it's a heat change required for forming 1 mole of substance, okay? And plus I have water. So, but here this value is given for forming only 1 mole of water. Yeah, refer to definition again. But I am forming here 6 mole of water. I have 6 mole of water, therefore I multiply by 6, and the value minus 286 kilojoules per mole. Okay, so I have done with my reactants. Now let's move to the product. So product is phosphoric acid, formation of phosphoric acid. So again, this one is for forming 1 mole of phosphoric acid. Therefore, I need to multiply it by 4 because I have 4 phosphoric acid. Okay, 4 minus 1,279 kilojoules per mole. Okay, so if you solve for this question, okay, let me just quickly solve. Okay, I got minus 416 kilojoules per mole. Okay, now let's move to the next question. So using Hess law, again we should find delta H for the main reaction. Okay, so you should find the heat of reaction for this main reaction, using the additional reactions here. Okay, so your main you should approach this type of questions. It's not asking you to draw Hess law cycle. Okay. So you should rearrange this equation in order to get that main reaction. Okay, just you should approach this mathematically. So the easy way to look substance by substance. So you have your carbon here. Okay, in your main reaction, you have your first substance is carbon here. So find that carbon in the additional reactions here. So where is it? So it is in the second equation here, and it is on the reactant side here, and I need it on the reactant side. So it is in the correct side, okay, on the reactants on the left side. Therefore, I will keep that equation as it is, okay, as it is. However, I need 2 moles of carbon, but here I have 1 mole of carbon. Therefore, I need to multiply that chemical reaction by 2. Okay, so if I do any change for the chemical reaction, I need to do the same change for the delta H of its value. Okay, so if I multiply by 2, that means I have to multiply its delta H value by 2 as well. Okay, okay, so let's rewrite it. Okay, so 2 carbons, 2 oxygens, and 2 carbon dioxide, and its delta H now is minus, so 2 times 393. Okay, so 786 kilojoules per mole. Okay, and the next substance in my main reaction is hydrogen. So where is hydrogen? Okay, hydrogen is in the third chemical reaction, and it is again on the correct side, on the left side, as I need it on the reactant side. Okay, so therefore I will not reverse it, I will keep it as it is. Yeah, but however, note I need 3 moles of hydrogen, therefore I need to multiply the third equation here by 3. And the same for with delta H value, multiply by 3. Okay, so let's rewrite it again. So 3 hydrogens reacting with 3 2/3 of oxygen, okay, and forming 3 moles of water. And again multiply its value by 3. So 286 multiplied by 3, so minus 856 kilojoules per mole. Okay, so next substance, I have oxygen here. So where is my oxygen? So it is in this. So it is in this part. Okay, in the second equation on the left side, and it is also present in the third equation on the left side as well. Yeah. Okay, and so it's also present in here. But let's look for the next main substance of ethanol here. Yeah, ethanol. Ethanol, so where is ethanol? Ethanol is in the first chemical reaction. And you see, in my main reaction, I need it on the product side, on the right side. But in the additional reactions here, it is present once it's participate in the reaction as a reactant, okay, on the left side. Therefore, I have to reverse this reaction, okay? So I need to reverse it. So first I write 2 carbon dioxide plus water, forming ethanol, C2H5OH, plus free oxygen. Okay, so I have reversed the chemical reaction. That means I need to reverse its delta H as well, the sign. Yeah, so if I have minus here, that means I have to make it positive. 67 kilojoules per mole. Okay, now my this minor equations is ready to be added. Okay, in order to get my main chemical reaction that I'm interested in. So I'm adding 2 carbons plus 2 oxygens. So first I need to write all the reactants, all the substances which is on the reactant side. So plus 3 hydrogens, oxygen, and now after finishing writing all the reactants, all the substances on the reactant side, I move on to the product side. 2 carbon dioxide plus 3 water plus ethanol, 3 oxygens. Okay, so now let's add add the same substances. Okay, so 2 carbons. Do I have any carbon? No, so I keep it as it is. 2 carbon plus oxygen. So I have oxygen here, okay, and yes, so if I add them together, I will get 2 sevens of oxygen plus hydrogen. Do I have any? No hydrogen, so 3 hydrogen plus 2 carbon dioxide. And actually, so this carbon dioxide may cancel each other because we have the same number here, yeah? This one and this one. So I don't write carbon dioxide, and I just water also cancels, okay? And I just write my products. So ethanol and 3 oxygens. So these oxygens will be, so we should move them to one side, okay? So let's move this one on the left side. So 2 carbons plus, so this will become minus. So if you subtract from the present oxygen, which is on the left side, okay, plus 3 hydrogen, forming ethanol. Okay, so now we have 1/2, okay, 1/2 of oxygen that we need. So now let's do with the delta H values. Okay, let's deal with delta H values on the bottom here. Okay, so I add my delta H values, so minus 786 plus minus 856 kilojoules per mole, and plus 1367 kilojoules. Okay, so if you do this calculation, okay, so you should get minus 277 kilojoules per mole. Okay, so this is your delta. It's a heat of reaction for the main for the main reaction where you are forming ethanol. Okay, this is answer for B.